Hello, I am Peter Townsend. I'm the director of Amanziflow projects, a South African company. We deal specifically in automated water control equipment. Amanzi is the Zulu name for water, and we've adopted that as the name of our company. Most dam failures are caused by inadequate spillways or failures of the spillway gates. And consequently, dam engineers are nearly always looking for a safe type of spillway gate, as the failure of the spillway gate is one of the major risks of dam safety. The early electro-mechanical gates were developed in the 1920s. That was the radial or tainter gate. The variety of type of gates is a vertical gate with wheels, and you have a fish belly flap gate. These are all different types of gates which are controlled electromechanically. But the history since the 1920s has been littered with numerous failures of these gates. Some of them catastrophic, some of them resulting in fatalities and drowning of thousands of people, as well as a considerable amount of damage to downstream properties. It's for this reason that the TOPS gate was designed to try and eliminate the risks associated with electromechanical gates. And the TOPS gate is purely operated and actuated by water forces alone, without any need for electromechanical equipment, and therefore it introduces another level of safety for spillway gates. An international engineer has defined this type of gate as a quantum leap in spillway technology, and the following will demonstrate its operation.
Hi, my name is Roger van Holt. I'm a director of Amanziflow projects, and today I'm going to show you the celebrated TOPS gate which Amanziflow has designed. Our MD, Mr. Peter Townsend, designed this gate for use in the water industry in South Africa. We're a South African company, and this is one of our best pieces of equipment. Let me quickly just show you the parts of the gate so that you can understand what I'm showing you today. It's an actual model of a project we did in 1998 called the Avis Dam. So what you're looking at is the existing spillway of the dam, where piers are cast in concrete onto the spillway, and then two axle units which then hold the pivot arm and the ballast tank of the TOPS gate in its position on the spillway. Now, the reason why this gate was developed by Mr. Townsend was in order to increase the storage of existing dams in South Africa, and we're hoping worldwide. The gates are automatically operating. They do not require electromechanical equipment. They do not require an operator. They operate purely on the upstream water level, and they actuate at the design level as designed. Cost savings related to the installation of these gates are much greater than a conventional raising, and we believe these gates represent a safer option to other electromechanically operated gates for obvious reasons. Floods don't keep time. They could arrive in the middle of the night and there will not be an operator, and there might not be electricity at the same time. The TOPS gate will open, and as it opens, it will release the flood and attenuate the flood through the dam. So these gates can be fitted in a short time, and one can avoid these large infrastructure projects where there's always cost overruns. So we believe the TOPS gate is the top gate in South Africa and hopefully in the world. So now I've shown you all the components of the TOPS gate. But let me explain to you how we've designed the TOPS gate to work. In this particular TOPS gate design, we installed a siphon connected to the ballast tank, which will prime at a certain water level upstream. So once the gate is fitted to the spillway and the dam starts to impound, as the water level rises on the upstream side, water enters the gate until the gate is full. At a certain water level, the siphon will prime and it will drain the water from this ballast tank. And the balance of forces around the pivot arms will then be such that the gate, as the ballast tank weight reduces, the upstream hydrostatic force will force the gate open. The gate will move away from its seals and it will then actuate, thus passing the flood and allowing the discharge which is required. The sequential opening of gates can be designed to suit the hydrology of that particular river or dam. In this case, we use the siphon, but there are many other ways to ensure the actuation of the gates automatically without the requirement of electrical supply or an operator. So let me show you how this gate opens automatically. Our model was built to illustrate with these weights, which you can't see hanging on this bar, to illustrate to represent the hydrostatic force, and the water which you can see in the ballast tank is the closing force. Right, I'm now going to show you how this top skate actuates automatically by simulating an upstream water level that is increasing. By pouring water into the gate, I'm simulating an increased water level on the upstream side. And if you watch carefully, you'll see the siphon priming at a predetermined upstream water level. Right. So what's happening here is the water level upstream has increased to the designed siphon height, which will then cause the siphon to prime, and this body of water in the ballast tank will be drained from the ballast tank by the siphon. As the siphon drains the tank, the weight of the ballast tank will reduce, thus reducing the closing moment around these pivot points and allowing the upstream water pressure to actuate the gate up and away from the spillway, as you can see it moving now. This is an automatic process purely on the height of the water upstream. The gate is moving away from its side and sill seals and not interfering with the movement of the gate. The water will now discharge over the spillway underneath the gate as the gate empties and moves away from the spillway. The gate will continue to open until the siphon's prime is broken, and then the gate will ride on top of the discharging water over the spillway, and as the water level upstream reduces, water will enter the openings on the upstream face, thus filling the tank, refilling the tank, and then causing it to recede back into its closed position on the spillway. In that way, retaining the increased full supply level, which was the original intention of the top gate on the spillway in the first place. Because of the large weight of the self-weight of the ballast tank, the rushing water underneath the tank will not cause vibrations, which is vital for this type of equipment. The inertia of this large ballast tank acts like a beam, and that resists any vibration, which several other gates are prone to under full flow conditions. This process is slow and not a fast movement, and the Vesconite bushes on the axles are self-lubricating, and the gate at the determined height will open. In fact, these gates fail and open. As you can see here, the siphon will now break and water will no longer be drained from the ballast tank. So once the siphon is broken, the gate rides on the discharging water over the spillway and will then refill and slowly fill from the upstream openings on the gate face and return to its closed position on the spillway, thus retaining the full supply level for which the increased full supply level for which these gates were designed. So I've shown you how this TOPS gate automatically actuates and returns onto the spillway. What I didn't mention is that we designed these TOPS gates to overflow slightly before opening. Some of the TOPS gates in the series on the dam are fitted with siphons, and that is to allow one or two gates to actuate first, allowing smaller return period floods to pass without all the gates actuating. The balance of the gates will be designed to overflow slightly, thus removing debris from the dam before they actuate. So in summary, the benefits of the TOPS gate are as follows. Totally automatic operation of a gate which returns to retain the increased full supply level, with definite cost savings in time and construction costs in comparison to other gates, with a robust, low maintenance construction which meets dam safety requirements. So clearly I've demonstrated to you today that the TOPS gate by Amanziflow is the top gate in the water industry today.